No, there's a bar magnet. It's having a pole strength m naught, this one. Then dipole and length, let it be. Now there are two axes. I'm going to define it. This is called as equatorial line. This is called as axial line. Okay, fine. So these are things, or bisector. Or broadside end on position, because there's a broadside. No, if you take bar magnet, there's a broadside, there's a narrow side. This is called like a broadside end on position. I think in SUMI they use a terminology like this, where the magnetic field on the broadside end on position. So it's talking about this particular thing. Broadside end on position means here, like, you know, on axial line. This is called like axial line. So like this. Now there's a bar magnet here. So now, so what is the physical? What is the geometrical length? So like what is the magnetic length? Will be 2L. So what is the dipole moment of this bar magnet? M into 2L into M naught. I would have written only L, but let me say that from equatorial line, the portion will be at a distance equidistance, L, let it be at a distance L. So what is the dipole moment equal? 2L into M naught. Now I'm going to cut this bar magnet. Let me cut that into two parts. I'll break up this into two equal parts. So I'll break up in this way. What will happen to pole strength? Pole strength will not change. Let me write here on the inside. And the magnetic length has changed. So what happens to the new dipole moment? M dash, will call it. So earlier what is M? Capital M, 2L M naught. Now what is M dash? M dash is equal to L M naught. So what happened to dipole moment? When you cut, how we are cutting? We are cutting normal to axial line. I'll cut the bar magnet into two equal parts, normal to axial line. Then I'll get two bar magnets. Then this will become south pole again. Again, don't think that south. This will be north. This will be south. This will be north. So dipole moment will become off. Now I can also cut this in. I'll cut this into two equal parts. Now what happened to the geometric length? Or what happened to the magnetic length has remained, and the pole strength is going to decrease. It will become off. So M naught by 2. M naught by 2. M naught by 2. M naught by 2, and this is 2L. So this is M dash. This is M dash. So I'm going to divide the pole strength. No, the mag charge is getting divided. So what is M dash? In this case will be 2L. M naught by 2 will be L M naught. I can cut this into n number of pieces. Not in this, I can cut this into n number of pieces. So like this, now we'll take the bar magnet. If I cut that into n number of pieces, what conditions will come? So I can cut it in many according to my requirement, that one. So if I cut that into n number of pieces, there's a bar magnet. 12 is there. So I'm going to cut this into n number of pieces here, so that n number of pieces will come here. Now what is the m dash dipole momentum of individual bar magnet? Will come like this. What happened the pole strength? I think inside here, I don't have space, so I'll just show two lines. Is it enough? The pole strength will not change, no, when you cut parallel to the bisector. What are two black lines? They are the pole strength. It will be south and north pole, that one. So what has decreased? The magnetic length has decreased. I'll cut that into n number of pieces here, n parts. Or what all these are? Tell me what I should do. What I shall write m dash of individual bar magnet. So what are these dots? Two parallel lines. They are the pole strength. Pole strength is not going to change. For only one, I'll show it. M naught, M naught. I'll cut that into n parts parallel to the or perpendicular to axial line. Then what is m dash? M dash will become equal to, first we'll write m. What is capital M? Capital M is equal to 2L into m naught. What is the length of each small n parts? I cut it. So therefore, m dash should be equal to, pole strength will be as it is, no? So what happened? The magnetic length got decreased. So 2L by N. So 2L M naught is what? M. So if you cut a bar magnet perpendicular to axial line into n parts, then the dipole momentum of each part will be M by N. Now we can also cut along the axial line. I think, okay, let me show it here. The length has not changed. Pole strength is going to change, no? When this bar magnet cut it. So a part of pole strength will come here, a part of pole strength will come here. So now when you cut it along axial line, if you cut it equatorial line, pole strength will not change. Magnetic length will change. If you cut it along axial line, then what happens? The pole strength is going to change here. The magnetic length will remain as it is. Now what is this M dash? Later on afterwards, I'll color it, then I'll post it. So pole strength has decreased by, so it is divided into say n parts. So what is M dash? M dash should be equal to, magnetic length is 2L. Then pole strength, how much it got reduced? M naught by N. So M dash equal to M by N. That is NP. So we'll do one thing. I'll change symbol. Some we'll use P something, huh? It'll be better. Let this be Q. P parts. Okay, Q parts like that. So fine. So now after this, so let me take a bar magnet. So this having a dipole moment M. I'm going to take a part like this. So let this be the some part. I'll take it. And now how to, what is this? This will be like this. P parts you can divide. I think we took that as Q, no? Yeah. And what is the dipole momentum of this one? The shaded one. Total dipole moment of bar magnet is M. The dipole momentum of this, let me shade it here. This M dash is what needed. Like that, if you cut this into P parts, then you are going to cut this into Q parts here. So what can be M dash? So shall we put M dash is equal to M by PQ? Q parts, P parts. Okay, fine. Sir, why we are doing S? In fact, in some of the applications where if the bar magnet is taken into 3/4 path, 1/4 path, no? So we should know, we should be in a better position to calculate the dipole moment of the remaining part. That's what the type of questions what you can encounter in exam. So they may ask you questions like this. If there's a bar magnet, this length is say A, this is B, pole strength they'll give value M naught. What is the dipole momentum of 1/4 of the part? What is this? This will become 1/4 of that one. 1/4 means how much it will become? B by 2. This will become A by 2. Then dipole moment of this, how much will become M naught by 2? What is this is M, this is M dash. So what is M dash? M dash should be equal to, what is the length? Length will become A by 2. This is M naught by 2. So this will become A M naught by 4. And what is A M naught? A M naught should be the dipole moment. Numericals. A bar magnet, 1/4 of it is taken and suspended. So how to calculate the dipole moment of that 1/4? This is a method. So you be careful. Very simple and very important in this one. The information will be so simple for you that when in exam such small things may trouble you if you are not alert. Okay, this is about the basic idea of the dipole moment. So it is similar to how it will be directed always from south to north pole. So this is the south pole. This is the north pole. Now this pole strength depends on what? There is one very good question. If you, I think some CBSE book is what he has gone to some extent here. Like he's telling on what factor the pole strength depends. Pole strength is telling. That means now some student they asked like, sir, I'll remove this pole strength here. You are saying something pole, you know, I'll remove this. I'll remove these two poles. Then there won't be magnetism, not like that. There's a representation. So if you remove this particular things like you just erase, then no magnetism, no, not like that. This bar magnet overall its magnetism, no, we do represent by this particular pole strength. The idea of pole strength is very important for us, or the magnet dipole moment. Now the pole strength, of a magnet, so right, depends on cross section, nature, and state of magnetization. Its cross section is definite, like a broad magnet, narrow magnet, cross section, nature, and state of nature means is it made up of nickel, iron, cobalt, or any other diamagnetic, paramagnetic substance. Then state of magnet, how much it got magnetized, how much how much the particular, see, iron is not a magnet, but you can magnetize it. How much you magnetize it, that will all determine the pole strength here. So there's a one in magnetic materials, you'll understand that magnetization means what, like nature and magnetization. Here, I think at least you are able to see the cross section of bar magnet that will determine the pole strength here. It's not saying the geometric length. You can see, I don't think so. Geometric length will have any influence. But when you cut this into two parts, you can see pole strength will decrease by half. So therefore, I'm bringing cross section. And the pole strength depends on these parameters here.